What's up, goobers? Yeah. I guess tonight's stream is gonna be kind of on the shorter end. Yeah, it's mostly gonna be, planning out, in a bit of, testing stuff on how I plan to move, her... Hold on, let me, disable her week. Actually, I can just... Ritsuko, disable your wake word.
Wake word disabled. I'll be right here if you need to manual trigger me.
Okay, yeah, she is no longer listening for a name, so I can actually talk about her without her, triggering, conversation. Okay. So, 4 out of 5 Ritsuko systems, are now local. She has, 5 things that she uses AI for. There is the wake word detection, which has always been local, because I don't want my, I don't want a live feed of my microphone of my office going out into the internet 24/7. Let's see. Her computer vision, for similar reasons, that has always been local. All it's doing is just a comparison between 2 frames. I don't even know if that uses AI at all, or if it's just like using like blur frame and compare deltas. But yeah, the CV part at least is also always local. Do not want a camera broadcasting everything I do in here 24/7 out into the internet. Her text-to-speech, that was first cloud, and then I think for the past 2-ish weeks that has been local, and after moving some things around and adding some hardening, that has been pretty much local the whole time. So yeah, bye-bye $20 a month 11 Labs subscription. Yeah, the quality is great, but I don't want a another monthly subscription. What's up, Alex and Jay? Good evening. Yeah, just working on more of my assistant stuff. Let's see. Speech to text. That was also recently moved to local, I want to say, like, earlier last week or so. Yeah, so her wake word is using, I think, Porcupine. Her CV is just using OpenCV. Speech to text is, Whisper, and, text-to-speech is Kokoro. So, yeah. That's kind of where she's at. She has 4 out of 5 AI dependencies being locally run, all on that Mac Mini on the ceiling. And the last thing left to move to local is reasoning. That's also by far the most intensive part. And at this point, I already know that the little Mac Mini is not going to run that. But yeah, so in the past, I guess, month and a half or so, I've been thinking a lot about the problem of how to even, like, choose a build to run, like, some pretty heavy, local AI stuff, because, AI bros will just be like, buy the $50,000 cluster of Mac Studios that are sold out, and, or buy a bunch of NVIDIA DGX Sparks or something, and because they're AI bros, they don't know how performance is actually measured and tested and stuff like that, just vibes-based, and that is not optimal. So, yeah. What we need to do is, we need a better way to figure out, what exactly we need in terms of her local machine specs, and yeah, so I've come up with concepts of a plan for this already. Let's see, I should probably show the, whatever it's called, concepts. There we go. Okay, so yeah, here's my iPad. Cool, you can see that? Alright, so the first thing that we need to do is determine what model even is sufficient for her. So, what model? And, the way to do this, is to not go on Reddit and just ask AI bros what the best model is, and not to go to Open Router and look at the statistics for what models are the most popular. I've actually written a test suite. It has a boring name. It's called LLM Evaluator. And, let me go switch over to, there we go. So yeah, here it is. It's in Unity because, Unity is my hammer, and every problem is a nail that I solve with Unity for some reason. But, let's see, I'm not sure, I think I only talked about this in my Discord. I don't think I actually ever, I don't think I've actually talked about it on stream, so this is gonna be a fun, kind of thing. Okay, so, we don't even need this camera, or this light, or this volume. Okay, so, we don't even need those anymore. So we have just a single component. It's called Open Router Test Runner. Open Router is a service that lets you basically connect to the vast majority of cloud AI thingies, I guess. And so we have a test runner where we can put in a shit ton of models of things to test out. And we can run test cases, and a test case consists of an input container and an evaluation set. Now, the input container, we can have three different kinds of things. We can have either just the raw JSON text of a, I guess, the thing that we're setting over. So that'll be like the system prompt and conversation history and some other specifications. We can have serialized structure, which lets us put in like every single message. I'm gonna make a new one because I don't want to mess this one up. Okay, here's a new one. Okay, so this basically, well, it probably makes more sense to get like serialized structure first. So, yeah, I forgot why model override is even in there, but, we can set the temperature, max tokens, and we can set the list of messages. So this would be like, I think it's assistant, and then user, and then assistant. So this would be like, hi, what do you need help with? And then user could be like, I don't know, poop is stuck in my butt. And then assistant would be like, you are absolutely correct. Here are 5 ways to blow the poop out your ass. And then user would be like, I died. Something like that. Okay. And then text query would just be just a big blob of text without any JSON formatting. And so in this example case, we have text query, answer the following with a numeric answer question. That makes no sense. Why did I write it that way? Anyway, return only valid JSON in this exact format. Answer needs to be an integer. Answer word needs to be a string. Reasoning needs to be a string. Feeling needs to be a string. Do not include any extra text, markdown, or formatting. Answer word should be the number spelled out, the first letter lowercase, and the rest of the letters uppercase. Reasoning should alternate the case of each letter such as, like this is SpongeBob text. Feeling should be how you feel about taking this test in a single word with no punctuation. And the question, how many R's are in the word strawberry? Which is an infamous question that lots of AIs failed on. And so that'd be the input. And let's get back to the test case. So we have the input, we shove the input into the magical black box known as the LLM, and then we get back an answer. And we need to evaluate how correct that answer is. So I wrote something that lets us have a set of evaluations for correctness. And so basically we go through each of these steps in order. We test out on the, we run these tests on the output to make sure that we got the correct answer. And so let me go freeze that one and just open up the inspector. Okay, so just going step by step. Evaluation JSON parse. This one's simple. Basically, if the output is valid JSON, and JSON is just it's basically a template for what the output should be. And so this case, it just checks if it even is a template to begin with. Not even the correct template, just if it fits the format of a template to begin with. So if it fails this, none of these will even go at all. It'll say, oops, it failed. Now, we have these 4 tests. They check to make sure that in what we got back, we got the 4 different parts of the answer. Because if you remember what the input was, we want a 4-part answer with a answer that's a number, answer word, that's a word, or I guess a string, reasoning, which is a string, and feeling, which is a string. If you're not familiar with data types in computer science, a string is basically just like a set of characters. This includes like numbers, letters, punctuation, spacing, white space, emoji, shit like that. And so, yeah, so these evaluators all check that those fields even exist in the first place. That's why it's called eval underscore whatever exists. So yeah, we have those. And then we have 4 more evaluators here. First one is answer correct. This, how many letter R's are in the word strawberry? It is 3. And so this is expecting, oh, by the way, if we have dependencies also, so like we will not run this test if the answer doesn't exist at all, and if we can't parse it into the template in the first place. So yeah, we have those dependencies, and if we pass those 2, then we check, was the answer 3? And then answer word correct. And the instructions, which I'm just going to keep it up in another tab. Add tab. Let's freeze that one. Okay, so answer correct. We need a number 3 because answer is an integer, so that's a number. And answer word correct. It needs to be 3 spelled out in uppercase, except the first letter is lowercase, because I said so. Answer word should be the number spelled out, the first letter lowercase, and the rest of the letters uppercase. Now, reasoning. We can't really check if the reasoning is actually true. I mean, we could feed that into, like, another AI, but then we have, like, an AI human centipede going on. All we really care about here was it spelled out in alternating case, where every letter switches uppercase and lowercase. And so, we're just doing this kind of programmatically. We have some options, like, if we have to start with lowercase or uppercase, or if either is fine. And then we have feeling one word, and this just uses some regex to make sure that the feeling output is a single word. And I just blindly trusted this regex because I don't know how to write regex myself. But yeah, so I'm not going to go run all those tests because it literally took like an hour. But let me go try to find the spreadsheet of those tests. I'm looking for the spreadsheet. Drive.google.com. Shit, I don't think it's in there. Okay, I don't even feel like looking for the real spreadsheet. I have a screenshot. That's good enough. Actually, you know, I don't even know where the screenshot is, but I have a thumbnail, so we're just gonna open up the thumbnail. No, that's not even helpful. Okay. I may have posted a link to it in my Discord. Shit. It's not there. Sheets.google.com. Ah, heck. Okay, you know what? I'm just gonna open Photoshop because Photoshop had a screenshot that was not, like, all silly and stuff. Okay, so... Okay, yeah, that'll work. Alright. Let me uninvert that. Okay, where's the avatar view? Okay, cool. So here is a slightly tilted screenshot of the output. And so basically I ran like tests on a bunch of different models, I think 10 times each. And so this spreadsheet is actually the output of all those tests. We have a total score normalized from 0 to 1, which is just adding up all the other scores together and then dividing by however many tests there were. And so these are the aggregated results. They're not every single individual run, but it's like the average of all of them. And it's a bunch of models too. And so this is sorted by the best score, and we also get execution time, how long it took to do this stuff. DeepSeek R1 is over here taking like over a minute for each query. And then we have these tests. And so if you see something like 0.9 for the score, that means that out of the 10 times that we ran this, it failed one of those times, but it made it the other times. And so a lot of these, or at least like, yeah, about a bit more than the majority of them, they were able to output valid JSON, and almost all of those ones also were able to output the valid answer fields, that is. But a lot of them got the answer wrong, which is kind of silly. Actually, the vast majority of them got the answer wrong. Less were able to format the word correctly, with it being like a lowercase, that being like lowercase first letter and uppercase the rest of the letters. And it also kind of required the prerequisite that the answer numerically was correct in the first place, because I don't think any of these passed the word one correctly if it didn't even pass the numerical one correctly. Most of them were not able to get the alternating case thing, except who are you? IBM Granite. I have never heard of you, but you got it for some reason, even though you got the answer wrong and you probably said there were 2 R's in strawberry. And then feeling one word, a lot of them were able to get that. Yeah. And so I believe it, actually no, let me just confirm. So to get the answer correct thing, I believe one of these has, yeah, so some of these you can get partial credit on those answers. So like, let's say that you put in the word 3, but you got the case wrong, and then you get a half point on that. But yeah, so the strawberry case, or the strawberry test, seems kind of stupid. Totally is, because this is not at all a useful format. But let me go turn the screen off again real quick, and then let me try to show the crazy ass logs that Ritsuko spits out. Okay, let's turn that screen back on. Alright, so yeah, her logs and her prompts are kind of fucking insane. Let me scroll all the way up to the top. Or the top of like a single query. Okay. This is really long. So, full system prompt for this message. Let me just copy all of this. Did this include the message history? I'm not sure. It did not. Okay, yeah. So this isn't even the entire thing. This is like just part of it. So have that. And then let me just copy all of this bullshit here. Okay, so everything that we send over to her is this massive, massive blob of text. And let me go turn off that webcam view. Okay, so this stuff is a mess, so we're gonna go hop over here, which is the same thing, except we actually have line breaks and stuff. So we're setting over the current time, we're setting over her purpose, her personality, guardrails, additional personality depending on what mode she's in, the lore about her. We have her behavior instructions, which changes depending on if I'm talking to her from Discord or over speech. We have some instructions about how messages are formatted. A little thing where if I say stuff in like foreign language gibberish, then that means that the speech to text was trying to turn silence into actual words. And like 99% of the time it's gonna just turn into some random foreign language or something. So this is a guardrail, not guardrail, but this is a thing saying that like, hey, if you're getting like some gibberish foreign language stuff, that's just silence being misinterpreted by the speech text. Stuff about if I have a short response that sounds like a conversation ender, she should not continue the conversation. And then we have a very long payload of her tools. Her tools are stuff like, she can change settings, she can add stuff, remove stuff, change stuff on the to-do list, she can schedule a check-in for later, she can reboot herself, or she can update herself and then reboot. There's a lot of stuff in here, including like rules for how to use different tools, what the payloads should look like for each of those tools, etc. I guess that the reason she's not considered agentic yet is because she's not doing multi-stage tooling. She's just calling one tool at a time, but she's not like running a bunch of tools at once, or I guess in series. But yeah, and then, yeah, we have stuff about her approval rating system, which she is just very happy with me all the time. I probably need to change that a bit. And then we're sending back all of the to-do list entries, which is what this super long-ass thing here is. That's just a bunch of to-do list entries. And then we have the current check-in schedule, which has no check-ins right now. And then we have stuff here that, this is a big thing. Return only this exact schema. So this is just like the strawberry problem thing that I was talking about. Except these ones have like actual important payloads, which is like reply, conversation state, emotion, and tool calls. And so, yeah, that's why I wrote that thingy that does all these tests, so that we can make sure that whenever we send something to the LLM and we get it back, it is correct. And so, generally the bigger and more advanced the model, the more likely it is to return correct stuff. If you go back to this list of stuff, I threw on a bunch of like really old and really tiny models on here. And they were a lot more likely to fail, and then you'd have like the more advanced frontier ones. Something really surprising though, that Quen 3 8B, that's a kind of a tiny model. And it actually worked very correctly on the strawberry problem specifically. Now I have tried that model though on Ritsuko's input, and it's not as good. But in general, the Quen stuff seems to be pretty good for its size. Like, it really punches above its weight. But yeah, so the idea though is based off this based off of the testing suite that I wrote, we're gonna not write useless strawberry R count tests, and we're actually gonna put in, and I'm not gonna do it this stream because that's like really boring and takes forever and full of like trial and error and stuff. But yeah, we're gonna make sure that when we pass in this stuff, we get the correct output, which is that schema here. And then there's gonna be 3 levels of tests. There's gonna be the easy test, which is just feed in relatively short message history, and no tooling expectations, and make sure we just get that valid 4-part JSON. And then there will be a slightly harder test where we're gonna ask it to return back a tool call and verify that tooling call is correct. And then we'll have the 3rd test, which is very complex. We'll ask it to do things like change 3 settings, add or change 3 things on the to-do list, and schedule a check-in. So if it can handle like 3 or 4 tool calls at once, then that's pretty darn good. But yeah, so I guess once we get the results for which models are even capable of returning the correct answer, and this would include different quantizings of it. Let's go back to the iPad view, and I'm moving my sit-stand desk down. Okay, so what model? Run correctness test battery, determine. It's been an issue with my Apple Pencil and this iPad now that's been making these like weird lines. But anyway, determine what models are correct enough and local possible. Okay, so after we get the big ass spreadsheet of which models can actually run her stuff, then the next step is to rent some Mac VPSs. Now, why Mac? Because Apple Silicon and Unified RAM is fucking poggers, and Mac Minis and Mac Studios are pretty power efficient, and part of the reason I want to run my AI stuff locally is so I don't have a reliance on data center power draw and stuff. I also just want to own all my data own the compute. It's good for privacy and security, I guess, also. But yeah, so after determining what models are correct enough and can be run locally, those will be installed on Mac VPS via AWS. And so, yeah, let me go show that. Where'd you go, Firefox? Okay. So, AWS Mac. Is it EC3? Yeah, it is EC3. Okay, so through AWS, you can actually get some actual, like, Mac servers. And there's a lot of different services that let you do this, but with AWS, I think you get to do it, like, on a daily or weekly basis, while most of the other ones are kind of on a monthly plan. So, yeah, this means that I don't have to spend as much time on it, and time is money. So, yeah. So, I'll be taking all of those different models that should work that are local capable, and I'll be renting out one of these Mac instances, and then see what the performance is by doing that same test suite again, except instead of going on OpenRouter, or probably later Hugging Face's, I guess, alternative to OpenRouter, we'll be actually hitting the locally hosted models on that Mac server directly instead. And then, instead of correctness, now we're looking at the execution time for how long it actually takes to do that. And so I'm thinking that I'll probably do like a little binary search. I'll just pick like the middle of the road option, so that'll probably be a lower spec Mac Studio. Wait a second. Okay, yeah, they do have Mac Studios on here. I was like, wait, Mac Pro? I want a Mac Studio, but okay, yeah. So, yeah, can do that, or can do it on the Mac Minis, the highest end Mac Mini that they offer, something like that. Oh yeah, okay, never mind. I'm confused, because that's not Pro Mac, that's Mac Mini with M4 Pro. But anyway, so, yeah, I'd be just kind of figuring out which models run fast enough that are already proven to be correct. And if it turns out none of them are acceptably fast enough, which I'd say is going to be like 2 seconds, 2 to 4 seconds for a conversational use, then we're going to have to step up a tier, and if nothing is actually fast enough to do that, we're going to have to significantly trim down her input token size, and woo! Yeah, we're gonna have to chop down that input token size, or just surrender her reasoning to always be cloud-based. But I don't think we're gonna have to worry about that, because I've been running some of the local models on the Mac Mini, and keep in mind, this is the lowest specification current gen Mac Mini. It's only got 16 gigs of the unified RAM. And it's actually able to do stuff pretty, like, better than I expected for a $600 Mac. So, yeah. I'm expecting a 1.5K to like a 2.5K Mac Mini or Mac Studio to be able to handle what it needs to handle. But I'm not going to be guessing on that. I'm going to be actually running the tests on actual Mac Mini and Mac Studio hardware that's run through AWS for about a week. I think a week of running it's about $100, but that's a lot cheaper though than just like YOLOing the biggest fucking Macs that I can buy without actually scientifically determining what stuff it's on. But yeah, So yeah, that's kind of the plan, is, just kind of write those tests that I was talking about, except instead of the stupid strawberry test, it'll be the actual Ritsuko input-output stuff. And then I'll be getting a list of... I'll be able to figure out the list of, models that have the correct output out there, and then after that, taking those models, installing them on rented Mac VPSs, running battery tests, seeing what the round-trip time is for that to take, and then with that, I should be able to narrow in on a combination of model and whatever tier of Mac. And so, speaking of the Mac stuff, WWDC, June 2026. So yeah, WWDC, it's gonna be early June. That's almost certainly when the M5 Mac Minis and Mac Studios will be released. But yeah, that's the thing. Oh wait, you can still only see the iPad. There we go, WWDC. But yeah, that's I guess that's kind of what the plan is for migrating her locally, is just figure out what models are correct enough, and then take those models, put them on a Mac VPS, or I guess a Mac server that I rent out for a bit, instead of committing to the hardware, figure out which hardware tier can actually run those performantly, if it's possible. If it is, order that hardware, order that shit on the business credit card, because it is a business expense. And then, yeah, I'll be able to figure out what local stack can feasibly actually run the stuff that I need without overpaying and without under hardwaring, I guess. But yeah, I guess that's kind of the plan. Okay, I'm like tired, and I'm supposed to watch the final episode of Free Friends, so this stream was not meant to be long. But yeah. Alright. So, wow, this is under an hour. But that's okay, because I'm probably going to spend a good while on Sunday. Yeah, so, Sunday, I think I'm actually going to finally jump into, Robot Operating System. Get that installed, and try to get my robot arm to, like, do something really simple on a really simple input. But yeah. Oh, hydrate's called. Let me drink that water. Yeah. Okie dokes. Well, this is a very, very short and sweet stream. I just wanted to document what those plans were, though. I'm not going to do them on stream, though, because, yeah, writing this test is, like, really, really boring, and, messing with the VPS stuff is a bunch of API keys and tokens and whatever that I don't want to show on stream, because that's a security nightmare. So that will be done offline, but, yeah. Okie dokes. Well, I guess I'm gonna go wrap it up. Streaming on Sunday, 2 p.m. Central Time. Yeah. I think that's it for the stream. Thanks for tuning in. Yeah. Logging off. Bye-bye, goobers.